Hello, my name's Dawn Colley and I work for the Manx Wildlife Trust, and today we're going to be talking about leaves and leaf litter. So we've come back to Claughbane and we're standing underneath the deciduous part. In fact, we're standing under a beech tree at the moment, which I can tell from the zigzags pattern on the branches. So first of all, let's have a look at the leaves and what they do for plants. So we're going to have a good look at this holly bush here, which being an evergreen still has its leaves on. So why do plants have leaves? Well, really they're the powerhouse for the plant. So to be able to function, a plant does something called photosynthesis. For photosynthesis we need carbon dioxide, which is in the air all around us, okay? It needs nutrients, which it gets from the soil, and it also needs water. So the leaves are where it all happens. This is the factory of the plant. Leaves are nice and flat, and if you look, they're pointing upwards. The spread of the leaves, an awesome plan is to catch as much light as possible. This little holly bush here is a bit overshadowed here by this beech tree. Branches are coming out, its leaves are pointing to the maximum amount of light that it can get. So they're this lovely flat planar structure. So if we look at a leaf, the top side is often darker green than the underside. Can you see that? You can see this against the other leaves, but this is lighter. That's because the top side is pointing to the light the most. Just had a lovely fly disappear then, I don't know if you noticed. So it's darker green because it's got cells in it that contain something called chloroplasts. Chloroplasts take that sunlight, convert it into energy. So there we are, we've got sunlight for our photosynthesis. What about the carbon dioxide? How does this leaf draw in the carbon dioxide from the air around it? Well, on the underside of the leaf are tiny little holes called stomatas. And the air literally can get into the holes. Okay, then the carbon dioxide diffuses through the leaf. By that leaf being so flat, it doesn't have a long way to go with that carbon dioxide. So the carbon dioxide enters the plant through the holes in the leaf. So we've now got the carbon dioxide, we've got the energy from the sunlight, we haven't got the water. And the water is being absorbed from the roots and being pulled up the plant through the xylem, okay, and gets the leaves. It travels through the midrib here. It travels through the veins in vascular bundles, okay? So when it gets there, these lovely cells at the top of the leaf are busy using that energy, they're using the nutrients, they're using the carbon dioxide, they're using the water, and they're producing sugars for the plants to be able to grow. All that in a leaf, absolutely amazing. Fine for the holly leaf because this is an evergreen. Its cuticle, that's the same as our skin, the outer layer is very waxy, it's not losing a lot of water. If you're a beech tree like this, you're losing quite a lot of water through the leaves. So you need that power, that sunlight, to drive all that sucking water up. Wintertime, we don't have a lot of sunlight. So the best thing, it would just lose too much water, is actually to drop the leaves. So the leaves on deciduous trees drop down to the forest floor in winter, and we get this lovely leaf litter. And we're going to have a bit of a closer look at this leaf litter now. So we're going to be looking at the leaf litter here. This is the lovely leaf litter. If I just put it here, if I just pick some up, you can see we've got a very mixture of leaves. We've got a bit of a oak leaf there, another oak leaf. This is a beech leaf. And if I look, if I pull it from here, you'll find twigs in the ground. And if I keep looking, here, this very soggy looking round thing is actually from a beech tree. So which is hardly surprising because we're just underneath it. So leaf litter is actually comprised mainly 80% leaves and 20% other matter. So on the top here, we can see the leaves, they're really quite distinct. Okay, we can see the twigs here. In fact, that's a very distinct ash twig just there. We're going to just put them in the bucket because I'm going to take some back and we'll have a look litter and what lives in it. Because if this didn't drop down, year after year after year, it build up and build up until we were completely smoking leaves. So there's an important sort of cycle going on here. So I'm going to dig down some here. So these are very distinct leaves, and we'll put them in there. Okay, oh, there's quite a lot of beech moss there. Okay, but now we're getting down. Can you see these leaves are really beginning to break up? Okay, so we're getting down to what we call the fermentation layer of the leaf litter. This is when the leaves are starting to decompose. So I'll keep digging down and putting my leaf litter in my bucket. And now, now I've got here, this is really getting quite compact. So this now, when we get into this where you can see it's more of a soil structure, we call this humus. Okay? So, before we leave this area, I just wanted to show you that with deciduous woods, it's not a blanket. The soil here tends to be a bit more neutral. And you can see that we get plants that are able to stick out through the leaf litter. What we're going to do is compare this to the conifer trees and plantation a little bit further out. So stick with me and we'll carry on. This is the tree that we were at last week. And I stopped here again, I just couldn't resist it because this is part of the process of breaking down that leaf litter, and it's showing really clearly here. So we have a piece of the branch just falling down here, and you can see these beautiful fungus on it. Now what we're seeing here is actually just what we call the fruiting body. So most of that is fine little hair-like threads that are running through that branch and breaking down this branch, making it ever smaller and breaking down the nutrients so that the trees around can then take those nutrients back up, and it becomes one big lovely cycle.
Button.
Okay, so now we've come a little bit further into the Claughbane plantation itself, and this was planted out with mainly larches and western hemlock, which are obviously evergreen trees. And just looking around, you can see straight away that the understory, that the ground floor of the forest doesn't have as much green in it, and there's a big reason for that. So if we look and have a close look at the leaf litter just here, when we look at it, it's comprised of needles. We've got a few beech leaves here because the beech trees are quite close by and it's blown in, and we've also got a sweet chestnut leaf just here. And these actually take a bit longer to break down, so leaves can take a little bit longer to break down. Typically within a year they'll have broken down altogether. Some species have more waxy cuticles, so it takes them a bit longer to break down. So I wanted to have a little look in the actual leaf litter here. Now with pine needles, they're very acidic, they create a very acidic soil, and worms really don't like that. And that's partly the reason why it takes so long for these actually to decompose in these areas, because the worms aren't pulling the leaves down into the soil because there aren't any worms there because it's too acidic. So if I just have a little look here, I think the last leaf litter layer was about 6 centimeters deep. This one, oh gosh, I'm going down quite far, right? So we've still got that layer, that top layer, the leaf litter layer, the L layer. Then we've got the fermentation layer where it's just beginning to break down, and I've just reached down here some of the humus. So it's actually quite a deep layer, and what you tend to get in these sort of woodland areas is a lot springier mat, about 20 centimeters to 40 centimeters of pine needles just built up before they really start to break down. So there you go, there's a massive difference, and you can just see it visually just looking around.